Here are some examples of problems about the half and double angle formulas. Problem 1. Find the exact value of cosine 2 theta, sine 2 theta, cosine theta over 2, and sine theta over 2 if cosine theta equals 1/6 and 0 is less than or equal to theta less than or equal to pi over 2. To apply the double and half angle formulas, we need to know what sine theta is in addition to cosine theta. So let's use the Pythagorean identity to get sine theta equals square root of 1 minus cosine squared theta. Now since theta is between 0 and pi over 2, it'll be the positive square root. Now this is equal to square root of 1 minus 1/6 squared, which equals square root of 1 minus 1 over 36, which is square root of 35 over 36, which is square root of 35 divided by 6. Now we can apply the double and half angle formulas. We know that cosine of 2 theta is equal to 2 times cosine squared of theta minus 1, which equals 2 times 1/6 squared minus 1, which is equal to 1 over 18 minus 1, which is minus 17 over 18. Next, we have sine of 2 theta equals 2 sine theta times cosine theta. This is equal to 2 times square root of 35 over 6 times 1 over 6, which is equal to square root of 35 over 18. And now for the half angles, we have cosine of theta over 2 is equal to square root of 1 plus cosine theta over 2. Now this is again a positive square root, since theta being between 0 and pi over 2 means theta over 2 is also between 0 and pi over 2, so cosine theta over 2 is positive. Now this is equal to square root of 1 plus 1/6 over 2, which equals square root of 7 over 12, which is equal to square root of 7/3 divided by 2, which is equal to square root of 21 over 6 if we divide and multiply the fraction by square root of 3. Finally, we have sine of theta over 2 equals square root of 1 minus cosine theta over 2, and this is equal to square root of 1 minus 1/6 over 2, which is equal to square root of 5 over 12 instead of 7 over 12. Now we can do the same thing here as we did before and get square root of 5/3 over 2, which is equal to square root of 15 over 6. Problem 2. Verify that tangent squared of x over 2 is equal to 1 minus cosine x over 1 plus cosine x. Let's start with the left side. We have tangent squared of x over 2, and let's write this in terms of sine and cosine to make it easier. This is sine of x over 2 divided by cosine of x over 2, and then squared. Now we can use the half angle formulas. We know that sine of x over 2 is equal to plus or minus square root of 1 minus cosine x over 2. And then we know that cosine x over 2 is plus or minus the square root of 1 plus cosine of x over 2. And then this is squared. Since we're squaring this expression anyways, we don't need to worry about the plus or minuses. So we have 1 minus cosine of x over 2, square root, but it's squared, so that cancels out, divided by 1 plus cosine of x over 2. Finally, if we multiply both the top and bottom by 2, we're left with 1 minus cosine x divided by 1 plus cosine of x. Therefore, this is an identity.